Okay, ladies and gentlemen, let's take a look at these problems here. Our first one is asking us to find the volume of 200 grams of this unknown substance when mass is related to volume on this model of density, or this graph. So if we find the 200 grams right here and go over to where the line intersects and then head down, it's approximately 80, slightly less than 80 it looks like. So 79 or 80 cubic centimeters would be a good answer for this one. And you can see I'm just going to go straight down from here. I'm just to the right of the 80 line. So 79 0.5 maybe cubic centimeters at that point right there. Problem number 2, we're asked to use the graph below to predict the mass of 600 cubic centimeters of copper. So I find the 6 cubic centimeters of copper, I go up to where it intersects the best fit line, and then I go over. So this looks like it's going to be approximately 50 grams. Okay, and then our last problem here, use the graph below to determine the volume of 40 grams of gold. I find the 40, I go over until I get an intercept, looks like right about there, and then I go down. So we have 1.5 here, these are tenths it looks like, so 1.1 cubic centimeters. So I'm going to go straight down there from here. 1.1 cubic centimeters. Alright, let's take a look at our next problem set using dimensional analysis. For this problem, number 43, use dimensional analysis in given densities to make the following conversions. 14.8 grams of boron to cubic centimeters of boron. So our known 14.8 cubic centimeters of boron, this is number 43, and we want to change that, oh, that was grams, my bad. These are grams of boron, and I want to take them times a conversion factor that's going to change them into cubic centimeters of boron. So 14.8 grams, but the density of boron is 2.34 grams per cubic centimeter. So what I know is grams goes in the bottom, cubic centimeters goes in the top, because grams are going to cancel grams here, and don't forget I can write a 1 under there if I would like. And then I have 2.34 grams for every 1 cubic centimeter. And to simplify this problem, I haven't done this on the video yet, but I think I did it in class. 14.8 grams times 1 cubic centimeter divided by 2.34 grams. Okay, so now we can see here's the grams canceling the grams, and we're left with cubic centimeters, but I still have to take 14.8 times 1 divided by 2.34, or I can just take 14.8 divided by 2.34. For 6.3247, I have to decide how many significant figures. I have 3 significant figures here. Conversion factors don't change my number of sig figs, so I'm going to go with 3, 6.32, and that's where I'll stop. Alright, let's do number 47, sorry, 43B. Okay, 43B, 4.62 grams of mercury. Mercury is H G, and I'm going to multiply that times a conversion factor with grams in the bottom. I want to convert it to cubic centimeters, so I put cubic centimeters on the top. And then I clear my calculator, throw in the 13.5 grams here, 4.62 divided by 13.5, 0.342 cubic centimeters. Okay. Grams cancel grams. I could put this over here just to be clear. All right. Let's take a look at number 44. For 44, we have rework the preceding problems by applying the following equation. Okay. So, since density equals mass divided by volume, if I know the density from the previous problem, let's do A first, I would say 2.34 grams per cubic centimeter equals mass over volume. I've been given the mass, 14 point, oh sorry, you can't see that. So I was given the density right there, that's D. This is the mass right there, and the volume was our unknown. So down here I wrote density, replacing the D, mass, 14 grams, and volume is my unknown. So I'll just put V, cubic centimeters. Now to solve for V is a multi-step problem. I have to multiply both sides times V. So I'll put this over here, V times V. Now V cancels V on this side, and I'm left with 14 grams equals 2.34 grams per cubic centimeter times V. Well, to get V isolated, now I need to divide both sides by 2.34 grams per cubic centimeter. So on this side, I divide 2.34 grams per cubic centimeter. Okay. So when I do this, 2.34 cancels 2.34, and I'm left with V equals 14 grams divided by 2.34 grams per cubic centimeter. Okay? Now grams cancels grams because they're above and below, but this cubic centimeters doesn't get canceled, and when you have a denominator in the denominator, it becomes the numerator. So our final answer will be 14 divided by 2.34 cubic centimeters. So we get our units back, and that's what we needed. So 14 divided by 2.34, if you look up here, is exactly what I did, and it gave me 6.32 cubic centimeters of boron. I'm going to bring that up so you guys can see that. Sorry about that, I wasn't watching the screen. Just to review, I was multi-steps here, and you can see it's a little confusing to cancel volume, get it over there, then to divide by the density, get it over there, and you can see how using dimensional analysis might make more sense here. Let's try letter B, and you can see right up here is my answer for letter B. I've got the density, put that big D there, here's my mass, and my volume. It will start out as my unknown. So solving the same method, density equals m over v, this time I'm going to work through with the variables. V times both sides. Now I have VD equals m, because V cancels V. And I want to get V by itself, so I have to divide both sides by D, and D cancels D, and I have volume equals mass divided by density. And I'll slide this up a little bit so you can see that last step. V times D divided by D equals M over D. D's cancel, V equals M over D. Alright, so the last thing I had to do then is actually put some numbers in here. So I go back to problem number 43B, and I look, and 43B says that density is 13.5 grams per cubic centimeter, and mass was 4.62 grams. That's going to give me a volume, and my volume is 0.342 cubic centimeters. All right, that takes us to number 45. What is the mass in grams of a sample of cough syrup that has a volume of 50 cubic centimeters? So we're given 50 cubic centimeters, and we're going to multiply by a conversion factor, and we're going to find what is the mass in grams. Okay, so that means cubic centimeters needs to go down here, grams needs to go up there, and the density is 0.950 grams per cubic centimeters.
Okay. I'm here to take the quiz.
I'm going to finish this problem up and I'll take care of you.
No.
So the next step then is to take 50 times 0.950 to get our answer. 50 times 0.950 equals 47.5 grams.